Okay, so this is the setup for the circuit that is simulating what is going on in the car in each of the 8 sensing sites that are on the sensor board that is on the bottom of the car looking down at the road surface. You can see that we have an oscilloscope, we have a power supply, and then we have a circuit here. And I'm going to sort of try to focus in on the circuit a little bit more here. See if I can zoom in a bit and point out the various parts. Right here is the power supply. The red is always plus, of course, and the black is always ground. That's a very good convention to follow in the lab. This is the wire here that these are the cable that connects to the oscilloscope, and you can see that the plus side of the oscilloscope is connected to the top of the capacitor and the phototransistor, which is right here. This is the capacitor, this is the phototransistor. Remember, this is a visible light phototransistor. You don't have visible light phototransistors in the car. They will be infrared only, infrared, so that we don't have to worry about ambient visible light. We still have to worry about ambient infrared, which is what you may have when you are in a room with a window to the outside that's open or that has the shutters drawn back, and so light can come in. That sunlight has infrared frequencies in it. So we still have to worry about that, but not the visible light. So this is the 220 ohm transistor. If you can see it, the bands are red, red, brown. That's 2 to 1, 22 times 10 to the 1, 220 ohms. So this is the circuit. You can see that this end of the resistor is connected through the yellow wire to also to the top of the capacitor and the phototransistor, just like the circuit is shown in the lab manual. Okay, so that's what the circuit looks like. Now I'm going to move back out and try to focus more on the oscilloscope and the whole circuit. Maybe I'll move it over a little bit more. Okay, I guess I'll go into the oscilloscope maybe and show you some of the settings on the oscilloscope. Okay, so what we have here is the, you can see right here, this is the little arrow that points at the 0 line for channel 1. The 0 line for channel 1 is this line right here. The trigger point is right there. It's just above 1 volt. And you can see that because up here in the corner that says 1.00 volts slash. The slash is per division, and there are 8 divisions vertical. So it's just above 1 volt. The trigger point is meant to work for both going up and going down, but crossing through this level right here. When the input signal goes through that level, the oscilloscope will trigger for a single sweep across the screen. There, and that's controlled by this switch here, where we see it says single. We're going to have just a single sweep, and that's it. It's not going to continually sweep across the screen. And so what we will see here is when I put the power to the circuit, that we will see that this capacitor will charge up, and we will see it charge up on the screen. And so I will show that right now. Well, I'm going to change the sweep speed, so it's going to go at there's 1 millisecond now. So I'm going to do this. Okay, and so what you see here is a phenomenon that is called contact bounce. Happens a lot with switches. But you can see what is happening here is the capacitor charges up very quickly. And why? Because you have only the 220 ohm resistor and a 2.2 nanofarad capacitor, very short time constant. So it's charging up very quickly, but then the switch comes together and then it bounces open and boom, it discharges, and then it comes together again. So it's doing this kind of thing, and that's what you see that it's happening right here. But finally, it ends up and it stays closed, and it's staying closed at 3.3 volts, which is what is essentially being set on the power supply. And so now the circuit, the capacitor is charged, and that is where that's where the car, this happens approximately 150 times a second in the car. The capacitor charges up, and then the circuit is changed so that the capacitor will discharge. And so now we're going to simulate that portion of it. I'm going back to a single sweep again, but we know that the voltage is up here someplace, and it's going to come back down to 0 when I disconnect. So when I disconnect, I get this. So now you can see that the capacitor has discharged, and because I've let an awful lot of light come in on the circuit, the phototransistor's resistance is rather low comparatively to other conditions where I have my hand over it like that, or I'm completely blocking the light. Low resistance this way. And so that's the end of this one. We'll go to the next video.